Okay, logarithms, part 2. On your calculator, you see an LOG button, right? And right above that, right below that, you also see an LN button, correct? All right. And right above that LN button, you see e to the x. And remember, f of x equal e to the x. That function right here, that exponential function, that's called your natural exponential. That's called the natural exponential function. Natural exponential function. All right, so whenever the base is e, that exponential function has a name. It's called what kind of exponential function? Natural. Okay. Now, the two more common bases, remember when we did all these logarithms, we had bases, right? We had base 3, we had base 7, we had base 36, we had base 8, and so on. Now I'm going to ask you this. Why is it I could not have asked you something like this? Let's make it 36, negative 3. Base negative 3. Because when we talk about exponentials, we mentioned that the base can never be what? Negative. It has to be what kind of number? Positive, and it cannot be what positive number? So when we did all those problems, did I ever have the base be negative? No. Because a base must always be what kind of number? Positive. Was this ever a 1? Did I say the log of 36? No. Base 1? No. Because the base cannot be 1 as well. So if you go back to all the problems, they were all positive numbers. At some point, you could also find this. You don't know how to do this yet, but you could find the log of 7.3 base 2.6. It's very easy to use your calculator with that, by the way. You can find that. Does the base always have to be a whole number? No, it can be decimals. Your argument can be decimals. We didn't use decimals because we were doing this by hand. We weren't using a calculator. So that's why we had to make the numbers easy. Yes?
Are you going to show us how to use our calculators to?
Yeah. Not today. Tuesday. All right. So I just wanted one thing I wanted you to make sure you understood was that in all the problems, none of them were negative because the base can't be negative. Nor what number? 1. Okay, now, on your calculator, there's an LOG button and an LN button. You see that? Okay. The two more common bases that occurs more often in sciences is base 10 and base E. Base 10 and base E. Those are the two more common bases. Those are the two bases that occurs more often than any other base. So if I have y equals 10 to the x power, and I want to change this to the exponential. I'm sorry, it's already an exponential. I want to change this to the logarithm. I'm going to say LOG with what base? 10. So 10 to what power? X. And what's my argument? Y. All right, now listen carefully. You see that LOG with base 10? See that LOG with base 10? I can also write it this way. X equal log of y. Notice, you don't see a base, do you? Don't confuse that. Normally, when you think you don't see it, it should be what? 1. That's not true here, because the base cannot be what? 1. If the base is not there, and it's written as log, it's understood to be the number 10. Log of y has what base? 10. Log of y has base 10. So there's no base there. It's understood to be base 10. So on your calculator, you can tell me what the log of 3 is approximately equal to. Because the log button in your calculator has what base? 10. It's understood to be base 10. So press log of 3 and tell me what you get.
0.477.
So let's do the nearest 10th. Point what?
0.5.
To the, okay, I'm sorry. Let's do the nearest 100th. I'm sorry, nearest 100th.
0.48.
0.48? Okay. All right, y'all, you understand that's base. What base is this? If you don't see it, what base is understood to be? 10. Okay. All right, so listen carefully to this one now. What if I had y equals e to the x? Y equals e to the x. Now, that one's called the natural exponential, right? This one right here, by the way, guys, this one right here, at base 10, that's called the common exponential. Exponential function. So this is called the common exponential function. Common exponential function has what base? 10. The exponential function with base b is called the natural exponential function. Okay. So if I want to change this to a log equation, I would say log with what base?
E.
E. So e to what power?
X.
And what's the argument? All right. Now, whenever the base is e, now remember, when we did that e to the x, that was a natural exponential, right? Natural, e, natural. 10, common, e natural. So whenever the base is e, another way to write this expression right here, another way to write log base e is this. ln of y. Do you see an ln button in your calculator? ln. In natural, L log. Natural logarithm. So natural logarithm has what base? E. Natural logarithm has base E. So, a while ago I asked you to tell me what the log of 3 is, and you said the log of 3 was 0.48, right? Right? All right, I want you to do this. I want you to change this right here to an exponential. What's the base? 10. So on your calculator, what's 10 to the 0.48 power? What's that about? On your calculator, go ahead and do it. 10 to the 0.48 power.
3.02.
So it's about equal to what whole number? 3. That's what this was, right? So if I take the natural log of 3, remember, LE means natural log. It's easy to remember because the L is log, N is natural log. On your calculator, we take the natural log of 3. What do y'all get to the nearest 100?
1.0, well, it's going to be 1.1 because it rounds.
1.1.
1.098.
Okay. 1.1? Is that what y'all got? Make sure you press the LE, not the LOG. Because LOG is understood to have what base? 10. LN is understood to have what base? E. So then what I want you to do, because we did this in a previous lesson, I want you to change this to an exponential now. What's my base? E, good. I'm glad you didn't say 10, because this is ln, not log. E to the 1.1 is about what? Use your calculator. Make sure you don't use your calculator. So get that E on your calculator, raise to the 1.1, and then what's that equal to? About 3.0, so it's about what? 3. Okay. All right, so your LOG button is understood to have what base? 10. Your LN button is understood to have what base? E. Okay. All right, now, one more thing. Tuesday, and we need to do this because on your final, they did put a log equation that you have to graph. So we do that Tuesday. So to get to that point, though, you got to find the domain. So remember, I can only take the log of what kind of number? Positive. We just saw that in a calculator. I asked you to plug in a negative number and 0. It didn't work. So the argument, your argument has to be what kind of number? Positive. So all you do is take the argument, and positive means greater than what? 0. Not equal to. Can it equal 0? No. Did the base matter here? No, I could have had base 7. I could have had base 6.2. The base has no bearing on my domain at all. It's your argument. And so all you do is solve for x. So what's my domain? Any number greater than what? Negative 2. That's your domain. Okay, so this is your domain. In interval notation, what is it? Parentheses, negative 2 to what? Infinity. Okay? So let's do one more. F of x equal log of x minus 5 base 6. Find the domain. How do I find the domain? I take the argument. What's the argument? And that must be what kind of number? Positive, right? Meaning greater than what? So you solve this inequality. How do I solve this inequality? Add 5 to both sides. So all your x's must be bigger than what? As an interval, what is it? Yeah, that's your domain. All right. And the reason I brought it up was because of this. Right here, A and B. You had to find the domain. And it said put it in interval notation. Okay? Now, you remember a while ago, I asked you this. 17. What is the log of 10 equal to? What's the base understood to be, guys? 10. So at this point, if there's no base there, it's understood to be a what? 10. So write it. So now you know the answer. 10 to what power is 10? 1. Okay? 18. Ln of E. Ln means LOG with what base? E. So the base is E, right? So what do you think the answer is? E to what power is E? 1. So remember, the original was this. So you have to know, though, that this is understood to have what base? E. Over here, the original was this. You have to know that this is understood to have what base? 10. What is the natural log of E to the 5th power? What do you think that equals to? What do you think, guys? 5. Because the base is understood to be what? E. right here, that's understood to be an E. So E to the box equal the argument. What's the argument? E to the fifth. The base is the same, the exponents have to equal. So what's the box equal to? 5. Okay? All right. So you have about 15 minutes. I just want you to get started on these two worksheets. So the first one is the first part we did, the part 1.